What's up, people? Welcome back to the dirt bike shed. About to get our chemistry on in here. Hope everybody's having a great day so far today. And what are we going to do? We're going to check out these chemicals right here. And we're going to talk about what it means to be soluble and insoluble. I've got some chemicals here to work with. Just to remind you, sodium phosphate, sodium chloride, hydrogen chloride or hydrochloric acid, sodium hydroxide, copper 2 sulfate, silver nitrate, and magnesium sulfate. Now, if we're talking about these things, we would have to say, what does it mean to be soluble? And what does it mean to be insoluble? If you don't remember, I did a video on like dissolves like, and that's on your Google Classroom. Let's think about something that we know is soluble. How about some good old-fashioned NaCl, some table salt? Let's prove that table salt is soluble. All right, I've got my mixer here on the counter in the dirt bike shed of chemistry. Here's the mixer. Now watch. I've got some beakers here. This has already got some sodium hydroxide in it. How about this bad boy right there? I've got a beaker, and I can take this little magnetic stirrer, put it down in there, turn this mixer on, and if you look, it spins that magnet. Now that's pretty sweet. Why would we want to spin a magnet in there? So we could mix something, so we can make something dissolve. I've got some distilled water here. Put a little distilled water in there. And you see the magnets mixing the water up. Now I'm going to take some of this salt. This table salt is a dry powder right now. And when I put it in the water, it seems to disappear. Now, what is that disappearing? That's what we call dissolving. And we say that this salt is soluble in water. Now that I've mixed it up, you can no longer see the salt. And I picked something really easy like that, so it will be easy for you to think about, because you've dissolved salt many, many times at your home while you were cooking. Right here I've got some sulfur. Sulfur is insoluble in water anyway. When we talk about solubility in this video, I'm going to talk to you about solubility in water. If I put a little sulfur in there, you'll see that it doesn't dissolve. And I could put a bunch in there and it wouldn't matter. And there's the sulfur still just floating around on top of the water. And it's dry. It's weird. It's very weird. But sulfur is insoluble. So when we talk about soluble, we think about something like NaCl. NaCl, it disappears in water. And the reason it disappears is because the Na and the Cl become separated. The water pulls them apart. We've talked about that in class. The water pulls them apart. Insoluble will be something like sulfur. And it doesn't disappear. It remains a solid in the water. Okay? Now we're going to do a little chemical reaction. We're going to use some sodium chloride and some copper 2 sulfate. And they are both soluble in water. Now what we're going to do first is we're going to look that up. And then later we're going to prove it. Well, let's look it up. How would we look up something in chemistry class? Well, you guessed it. We're going to go to our chemistry tables. I'm on page 6 here. And I'm going to blow this up real big. Because I know you're just looking on the camera and I'm filming this with my cell phone. So I'm going to try to make it plenty large. Alright. On the top of page 6 in your North Carolina chemistry reference tables, you'll see a solubility chart. Or a list of what's soluble and insoluble. And the things on this side are soluble. So what does that mean? These things over here If you put them in water, and remember we're talking about water, these things over here, if you put them in water, they're going to disappear. They're going to dissolve. All right? These things over here in red will not dissolve. So sulfur would be over here, and table salt will be over here. But it's a little trickier than that. The reason it's trickier than that is there are some double negatives. That's right. If you look at your charts, there are some double negatives. Swing this thing back over there. Double negatives. What do you mean, Mr. Perkins? That sounds crazy. Sounds like you're talking in class. Well, if you look over here, these things are soluble. But look closely and you'll see, let's look at our chlorides, the second bullet point right here. If you look at your chlorides, it says all chlorides are soluble. All bromides are soluble. All iodides are soluble. Except, see, there's our negative, silver, lead, and mercury. So if you had silver chloride, lead chloride, or mercury 1 chloride, they would not be soluble. They would actually fit over here in the insoluble part. So you have to be careful when you're reading these rules. There are exceptions. There are double negatives. Let me show you a true double negative. Let's look on the right side over here. Let's look on the right side. Over here, these are things that are insoluble. And all of these are insoluble. All of these, nope. Let's take a look at this second bullet point. All hydroxides are insoluble except group 1, strontium, barium, and ammonium hydroxides. Group 1 hydroxide. Group 1 hydroxide. What would that mean? It would mean sodium hydroxide. It would mean potassium hydroxide. It would mean cesium hydroxide. It would mean, if this is possible, you'll never see it, francium hydroxide. What should go on top here? That's right, lithium hydroxide. You know all of these guys right here, these guys are all in group 1, aren't they? So when it says group 1 hydroxides, that's what it's talking about. Let's go back now. Let's go back. All right, so we can read these charts, all right? All right, let's read this chart right here. Sodium chloride and copper 2 sulfate are both soluble. Let's look it up. Let's look up sodium chloride. Okay, looking on my chart. All chlorides except silver, lead, and mercury. So all chlorides are soluble. So sodium chloride, it is soluble. Check. The next one was copper 2 sulfate. All right. Look down here at this bottom bullet point, down here in the corner. All sulfates are soluble except calcium, strontium, barium, mercury, lead 2, and silver. Well, copper 2 is not one of those. So as far as we're concerned, all sulfates, in this case, are soluble. So CuSO4, yep, that's soluble. Now, I told you I would prove those were soluble, right? So here we go. We're back at the mixer. We'll put a little water in here. And I've already shown you that sodium chloride was soluble. So I've got some water here. Let me put some copper 2 sulfate in there. If you look right here, I've got some copper 2 sulfate. Everybody's got that in their dirt bike shed, right? Nope. Probably just me. Put a little copper 2 sulfate in there. There we go. Let that mixer run for a while. Now, mixing, just turned it up. Mixing definitely helps things dissolve faster. At home, you may mix things, you may shake things. Another thing you might do to help something dissolve better would be maybe to heat it up. Right? Shake well. All right, so I've got just about all of this dissolved. You should be, see, it's just a blue liquid now. I don't see any powder left in there. So we just proved that copper 2 sulfate is soluble. I'm going to take some of this copper 2 sulfate and I'm going to put it in a little test tube. Why would I do that? I'm going to do that so we can do a chemical experiment with it. There we go. And off camera, I took some table salt and I dissolved it in some water. So now you'll see that I've got a test tube with sodium chloride. It's dissolved, so we call that aqueous. I've got another test tube with copper 2 sulfite. Not sulfite, I keep saying copper 2 sulfate. It is dissolved, so we call that aqueous. We're going to take these two guys together and we're going to do a chemical reaction. All right, now here's what we did. We learned that sodium chloride and copper 2 sulfate are both soluble in water. And if you look back at the slide here, you'll see that we both looked that up and then we proved it in real life, right? So they're both soluble in water. Now, if we take a test tube with sodium chloride and we take a test tube with copper 2 sulfate and we mix them together, then we'll have a test tube that contains sodium sulfate and copper 2 chloride. Because this would be a double replacement reaction. The sodium here is with chlorine. Over here it's switched. Now it's with sulfate. The copper, instead of being with sulfate, would now be with chlorine. But we're going to see if this actually happens, because we're going to look up and we're going to see if sodium sulfate is insoluble. And we're going to look up and we're going to see if copper 2 chloride is insoluble. If neither one of those are insoluble, then nothing will happen. We'll just have a test tube with liquid in it, with dissolved liquid in it. Just watch. All right, here's a clear test tube. I'm going to put some sodium chloride in it. There's some salt water right there. All right? And now I'm going to pour, see this blue mixture, I'm going to pour some copper 2 sulfate in it. And hold your breath, see if something exciting happens. Did something exciting happen there? Are we looking at something new? Is this something wonderful? Can you see a little gel or something floating around in there? Well, the answer is no. It's just clear water. I mixed some blue water and some clear water, and now I have a little bit of water that's just lighter blue. Why is that? Well, let's look at the things we should have made. We should have made some sodium sulfate. Now I'm going to look on page 6, and I'm going to see down here that the sulfates, I'm looking in the bottom left-hand corner now, I'm highlighting it, that all the sulfates are soluble except calcium, strontium, barium, mercury, silver, and lead. So that does not include sodium sulfate. So sodium sulfate is soluble in water, so you wouldn't see it. Sodium sulfate would be, I'm going to write a little AQ here. I'm writing with the mouse. I apologize for that. Sodium, let me try it with the pen. Ready? Sodium sulfate would be aqueous. Aqueous, like Aquaman, means in water. It means you wouldn't see it. It's dissolved. Let's look up copper 2 chloride over here. Let's look up our chlorides, okay? Look up our chloride. Uh-oh. Oh, my board is freaking out. Hang on. See if I can get to work with the pen. There we go. Let's look up our chlorides. Let's look up chlorides. Okay. Boom. Chlorides right here. All chlorides are soluble except silver, lead, and mercury? Well, in our problem we have copper chloride, so guess what? That's soluble. That would also be aqueous. So guess what? Nothing would happen. If you mix these two aqueous solutions, you're going to come up with nothing. You're not going to make anything that is insoluble in the water. That was a long video and boring, but it's necessary because tomorrow's lesson is going to involve some cooler stuff. Here's what I want you to think about for tomorrow. What if I mix sodium hydroxide with the same copper sulfate we were using? This is aqueous. It's a little sodium hydroxide test tube of clear liquid. Here's my copper sulfate clear blue liquid. I'm going to mix those, and I wonder if the two things that we'll make will produce anything that is insoluble. If they do, then we'll produce something cool in the water, and we'll actually have a chemical reaction. So tune in tomorrow for that. I've got one more secret I'm slipping into the video. If you watch the video all the way to the end, this is the assignment. In the assignment on a Google Doc, you're going to type back, I watched the entire video. And then you're going to put this sentence. My favorite Supercross rider is, and then you'll have to tell me. I mean, I know we all have favorites, right? So you just tell me who your favorite is. You tell me who your favorite is.